Alright, welcome back. For those who were watching my last video on Gauss's method, this would be example 3, and we're still going to use the method to find the sum of a finite number of terms that are evenly spaced. And what you'll notice about this example here is that our last term isn't a number, it's an expression. And what this is telling us is that these numbers here are related in a certain way, and if I want to know any number in the list, I can use this expression here to figure out what it is. So just to make that clear, I'm going to go off to the side here and say the left column is n, and my first term is a 3, so I'm going to call this column f of n. My second term is a 7, my third term is an 11, the fourth is a 15th, and so what they've provided for us in this case is that if I want to know what the nth term in the list is, term number n, that is given by this expression for n minus 1. Alright, so like for instance, the next term, the fifth term, if we just follow the pattern, we know that every time we go up by 1 in the n column, we're going up by 4 in the f of n column. So that means that the fifth term should be 19. And that's exactly what you'll get if you plug in 5. So I'm going to put f of 5 equals 4 times 5 minus 1, which is, of course, 20 minus 1, which is 19. So that expression is working for us. So let's use Gauss's method and point out some important features about this example. So let's try a good color here, blue. Alright, so s equals 3 plus 7 plus 11 plus 15 all the way up to the last two terms. But s also equals 4n minus 1 plus 4n minus 5 plus 7 plus 3. So we're going to add these up and see what we get. So s plus s as usual is 2s. 4n minus 1 plus 3, well, ignore the 4n. Well, not ignore it, but that's going to be 4n. And then 3 plus a negative 1 is 2. So it becomes 4n plus 2. Plus 7 plus 4n minus 5, well, that's going to be 4n. And 7 plus a negative 5 is again a plus 2. And so what you'll notice is that's going to happen every time we add the pair of numbers. So I have 4n plus 2 being added up repeatedly. Now, you may wonder, as we wondered in the last video, how many 4n plus 2's are there? Well, this time it's actually easier to see than the last time, because go over to your table here. 4n minus 1 is our nth term. And if you start labeling the terms above the numbers we're adding, this would be term 1, term 2, term 3, term 4, I would have to put an n above the 4n minus 1. And that is all I really need to know, because every time I'm getting a 4n plus 2, that's coming from the fact that I'm adding the terms in the list here. And so there are going to be n of them because, well, I did that addition n times. So the answer is n. And so that means 2s equals 4n plus 2, adding up n of them, so that would be times n. And if you divide by 2, you get our answer. So S is equal to 4n plus 2 times n divided by 2. So we got an expression, and this is actually more powerful. It's more powerful than just getting a numerical answer. This is a closed formula. And we're now able to answer many questions. If I wanted to know what's the sum of the first 20 numbers on this list, well, all I need to do is plug in 20 for n. So S is going to be 4 times 20 plus 2 divided by 2 times 20. And so this becomes 80 plus 2, which is 82, times 20 divided by 2. I'm going to squeeze this up a little bit, shrink it up. And this is equal to 82 times 20 divided by 2 is 10. It's 820. So what we've done here is we've dealt with what's called an indefinite sum. This is an indefinite sum because the number of terms that I'm adding up is indefinite. All right, this is not going to produce a numerical answer. It's going to produce a formula which we've come up with.